The exam timer is literally ticking down. You've got maybe 5 minutes left on your Cambridge IGCSE Physics paper. Your heart is racing, right? You flip to that final page and boom, staring back at you is a massive 6-mark question on space physics. So you scramble. You scribble down some formulas, you plug in the numbers, let out a massive sigh of relief, and close the paper. But you know what you just did? You just walked straight into a trap.
Take a look at this orbital calculation. We've got a radius of 150 million kilometers and a time of 365 days. So the speed is calculated as 150 million divided by 365, which gives us 410,958. Now, that seems perfectly logical, doesn't it? Well, actually, scratch that. It is completely wrong. This simple, panic-induced mistake just cost a student a whole grade boundary. Why? Because they completely ignored standard units. They literally just divided kilometers by days without converting a single thing and then left the final answer completely naked without any unit attached at all. It's a total fatal error, and honestly, we see it happen every single year.
And this perfectly illustrates exactly where those marks just bleed away. Down at the bottom of the Cambridge IGCSE syllabus breakdown is Section 11, the Earth and Space. Now, space physics is a relatively new addition to the 0625 syllabus, and man, that makes it absolutely notorious for trapping unprepared students. Because we just don't have as many past papers to rely on, a lot of students just try to wing it. They rely on general knowledge. But here's the thing, Cambridge examiners are not testing your general knowledge. They are testing your exact pinpoint scientific rigor. So let's dive into the fatal exam mistakes in space physics, the specific diseases that will absolutely kill your exam score. First up, missing units entirely, like we just talked about. Then there's rounding numbers way too early in your calculation, which completely destroys your final accuracy mark. Or using the wrong variables altogether, providing vague middle school level explanations, and finally, writing conclusions that are absolutely not supported by the data table you were actually given. Listen, ordinary rote memorization of facts, it is not going to protect you from these specific errors when you're sweating under exam pressure. The crucial takeaway here is that memorizing the syllabus just isn't enough. You need a surgical exam strategy. Seriously, knowing that the Earth orbits the Sun is not going to get you the marks anymore. You need to know exactly how to answer when you're staring down those specific Cambridge command words, like explain, calculate, or evaluate. It's like a giant puzzle. You have to think exactly like the mark scheme, breaking your answers down into little components that physically force the examiner to hand over those points.
And to do that, we are going to use the surgical 4-step answer framework. Think of this as your absolute go-to checklist for constructing top-tier high-band answers. Ready? Step 1, state the core physics concept. Step 2, pull evidence or data straight from the question or table. Step 3, apply scientific reasoning to really connect that data right back to the concept. And finally, Step 4, use precise examiner wording to lock it all in. I'm telling you, if you run every single written answer through this 4-step filter, exam panic just disappears.
Now, before we put this framework to the ultimate test, I actually have a question for you. What is the single biggest examiner clue you are ignoring right now? Seriously, there is a trap hidden in almost every single data table Cambridge gives you. And if you miss it, your entire calculation falls apart like a house of cards. In just a second, I'm going to reveal exactly what that clue is and how it totally flips your answer. But first, we need to see this framework in action so that the clue just becomes glaringly obvious to you. So let's start the surgery. Take this classic, everyday student answer to the question, explain why a distant planet has a longer orbital period. The student writes, the planet takes longer to orbit because it is farther away from the sun. Now, that sounds totally true, right? I mean, you probably learned that back in primary school. But in IGCSE Physics 0625, this scores exactly 0 marks. Nada. It's dangerously vague, and it completely skips our scientific framework. Watch how we instantly elevate this flawed answer using our surgical fix. We'll start with steps 1 and 2. For step 1, the concept, we don't just say further away, no. We say a larger orbital radius means a longer orbital circumference. Then for step 2, the evidence, we explicitly note that this radius dictates the total distance the planet actually has to travel. Just by doing that, we are already speaking the examiner's language. Let's see how this builds when we bring in steps 3 and 4, scientific reasoning and examiner wording. Instead of just vaguely saying it takes longer, we state the gravitational field strength is weaker at a larger distance, resulting in a lower orbital speed to maintain the orbit. You see the difference there? We are combining a longer distance to travel with a slower speed due to weaker gravity. That right there is a bulletproof, maximum mark answer born directly from our surgical framework.
All right, the suspense is over. The examiner clue revealed, always check the units hidden in the data table headers. This is literally the single biggest trap you are falling into. Examiners absolutely love to hide non-standard units right there at the top. They're not going to hand you distance in meters and time in seconds on a silver platter. Oh no, they're going to give you average distance in millions of kilometers and orbital periods in Earth years or days. If you just rip those numbers straight from the table and dump them into the orbital speed equation, v equals 2 pi r divided by t, without converting them first, your entire calculation is dead on arrival.
Let's actually put you to the test with some high-stakes mock planetary data. Think about Planet X. It has an average distance of 150 million kilometers and an orbital period of 1.0 Earth years. Then, right below it, we have Planet Y, sitting at 300 million kilometers, taking 2.8 Earth years. Look really closely at those headers. Millions of kilometers, Earth years.
Now, imagine the student glances at that data and writes down this conclusion. Planet Y is twice as far as Planet X, therefore its orbital speed is exactly half of Planet X. I mean, it sounds incredibly logical, doesn't it? The distance doubles, so the speed halves. It just feels so right in the moment.
But pause and predict. Can you spot the two fatal errors in this conclusion? I want you to step right into the shoes of the Cambridge examiner right now. Feel free to just pause this explainer for a second and look really closely at the claim. Just run the data again in your head. 150 million kilometers in 1 year versus 300 million kilometers in 2.8 years. What exactly went wrong here?
All right, time for the autopsy of the answer. Here is exactly why that reasoning fails spectacularly. First off, the student just assumed a linear relationship. They assumed double the distance means exactly half the speed, without even bothering to check the math. Second, they completely ignored the actual time data provided. I mean, Planet Y takes 2.8 years, not 2 years. And third, they completely failed to use the required equation, v equals 2 pi r over t, to actually prove their claim. They totally skipped the evidence and reasoning steps of our framework and paid the ultimate price.
So how do we navigate this trap versus the examiner correction? Here is the exact gold standard wording. We explicitly state, using v equals 2 pi r over t, calculating with 300 million kilometers and 2.8 years proves the speed reduction is nonlinear due to weaker gravitational pull. By citing the formula, plugging in the exact data we were given, and linking it right back to the core scientific concept of weaker gravitational pull, you have completely dismantled the examiner's trap. You've basically guaranteed yourself a top band grade for that specific question.
Okay, so you successfully survived the space physics surgery. You've got the 4-step framework in your back pocket, you know to hunt for those sneaky hidden units and table headers, and you know how to link data straight to gravitational concepts. But here is the harsh, unavoidable reality. You are still bleeding time on the rest of the paper. Fixing your space physics answers means absolutely nothing if your overall exam time control is broken. Sure, you might lock down these 6 marks, but if you're bleeding time everywhere else, you are still staring down the barrel of dropping a full letter grade.
So what's the plan? You've got an unresolved problem with exam timing, and you need some serious post-surgery rehab immediately. The mandatory next step to lock in your target grade is understanding all the broader mistakes outlined in the Cambridge Examiner reports. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Seriously, head over there right now to master your exam time control and stop bleeding marks across the rest of your paper. Until then, I want you to ask yourself, are you losing precious minutes right this second because you are trying to memorize science instead of engineering a bulletproof exam strategy?